edition of the Heat Treat podcast. Today we have a power player of the industry, all the way from Michigan, the director of heat treatment from American Axle, and my dear friend, and I can say one of the most knowledgeable people of heat treating, Fred Hamizadeh. How's it going, Fred? Good morning.
Good morning, Carlos. How are you?
Doing all right. We're delighted to have such a power player and a delightful guest today on the Heat Treat podcast. We're gonna talk today pusher versus batch, pros and cons. And before we enter to the technical side, I mean, many people know you, but for the ones that don't know you, can you just tell us a little bit about yourself, what you do, the company you work for, and your career in heat treat, which is very wide?
Okay. First of all, thank you for the invitation. My name is Fred Hamizadeh. I'm the director of heat treat and general process equipment at American Axle out of Detroit, Michigan. I've been in the industry for about 35 years now, with my experience going as far back as in the 80s with Williams Industrial. And then I moved on to surface combustion, where I had various roles there as engineer and chief design engineer, and then in product sales. And then I moved 15 years ago, roughly, over to American Axle to take on the role as heat treat engineer. And I moved up through the corporation, learning a lot, being on the other side of the business. My background is mechanical engineering with some metallurgy mixed in there, but my main emphasis has always been the furnace design and the engineering of the components of it to build a robust or get a robust and fail-free type of equipment.
So it's quite an amazing career, because you were on the furnace side, designing and building furnaces for OEMs like assembly plants, and then you switch and you are the captive, right? And
right.
And besides of just designing the furnace now, you have to take in consideration the plant layout, the volumes, all the industrial engineering that comes not only with the furnace, but with all the auxiliary machines, the process that is previous to heat treat, and the process that is post heat treat, right? So right. It's a little bit of both, right? And also you travel worldwide to many,
yes,
to many countries, in many applications. But today I would like to focus a little more on the automotive sides in the States, right? So first of all, to start our technical background or technical conversations, there's different types of equipment. We're gonna focus today on carburizing mainly for automotive parts. So we always have a batch or IQ furnaces or UBQs or super roll case, how you want to call them. And then we got pushers, right? Yeah. So, and then now the trend is like kind of single flow, right? Maybe we can talk a little about that, right? So we got batch, pushers, and single flow. So coming from you, can you just explain for the audience that is not very familiar with these concepts, what's a pusher furnace, what's a batch furnace, and what can be a single flow process? Just really briefly, coming from you.
Okay, the simplest kind of furnace that you can use is a batch furnace, which is it's one batch or one load of parts going into the being processed in the furnace at a time. It's got a lot of flexibility into it because you're controlling one part, and the various portions of the cycle can be tightly controlled because again you're in one chamber, and you got tight control on that. And again, when you're doing the carburizing and the quenching, you can design the parameters for that quench, even with temperature and so on, to be able to optimize your load. So a batch furnace, depending also on the size of the batch, you can go very small, 24, 36, 24, or you can go to 36, 72, or even larger ones than that some of the people in the industry have built. I believe you might have built a couple of those yourself, some of those monster ones. And then, so the batch gives you the most flexibility. There's a lot of suppliers out there that use both in a commercial and in captive heat treat that only use batch. That gives them a lot of flexibility. But the batch also has its own downfalls too. You can a simple comparison on it is: do you want to take 20 people to a picnic in a bus, or you want to take them in individual cars?
Right.
Okay, so that'll be your individual cars will be your batch, and the bus will be your pusher. Okay,
right. You don't want to take a bus during COVID, right? But this is a different conversation, right?
You have to bring the C word into it.
Right.
So a pusher gives you the same if you have a lot of parts to run, a lot of the same parts that use the same parameters. The economics of it to use a pusher is much higher. As a matter of fact, a rule of thumb that we came up with here, it's 6 batches equals the price or equals the production of one pusher. But 3.5 batches, the price of 3.5 batches buys 1 pusher. So you can buy 1 pusher that equals the price of 3.5 batches and get the volume of 6 pushers out of it. Some of the simple items on it is you need one tank of quench oil in there versus on a batch you need 6 tank at
right
$60,000 worth of oil. That adds up to be quite a bit. The other thing is a footprint that you need to have on a batch. For every batch or every 2 batch, you need a preheat and you need a temper. In the pusher line, you need just one of those that have multiple positions. So the scales of economy is definitely on the side of a pusher if you have large volumes and you're making the same parts over and over again. That's why majority of our facilities, you see a lot of pushers, and we have batches for the onesie, twosie loads or the smaller loads that we have to run. Everybody has them. You have to have them for the flexibility, because downfall of a pusher is to empty it out to run it, to change a recipe or a changeover is very costly. It's a lot of downtime, a lot of empty pushes that you have to put through to change the setup. Now there'll be manufacturers out there say, oh, we can change our setup fast because we have multiple zones or multiple sealed zones in our pushers. But the downfall to their design is a lot of the square footage of the building goes up as they zigzag. They're designed through the to accomplish that. So that's just a little bit of a kind of superficial thoughts behind a batch and a pusher for a layman.
And can you just finish with the single flow concept?
Single flow has come around in the last for us in the last 4 or 5 years that we've been talking about. The thought of it is that it is the leanest way of manufacturing. In a batch or in a pusher, you get lots of parts. Each lot of part might have in a pusher basket, you could have 60, 70, 100 parts. In a larger batch, you could have 500 parts in it. Okay, so you get one lot of parts that comes out to you. Single flow gets you to the same level as machining of components, where you put it in a horizontal, vertical machining center. You get one part in and out, and you can control the process tightly if there is variation in wear and tooling and an atmosphere or so on. You can control the process a lot faster with a single part flow, and also be able to keep a history exactly on that part. The way we keep history is we keep a history on the lot, and we impart that history into the component as it progresses through the operations downstream. But the advantages of it is it's a very lean operation, and it depending on the type of equipment. If you get into a vacuum carburizing, the smaller chassis vacuum carburizers nowadays, or the best example of single piece flow is induction.
Induction.
If you can get induction into your system, you can put it right in there with the within the machining cell, and as the parts come down the stream from being hobbed or machined or washed, which is usually the last process before we get it, it goes right into that process, and out it goes into the hardening process.
And now, thanks for this very surface brief explanation of what is each process. Now, let's talk a little bit about cost. One of the biggest costs of furnaces, no matter if it's pusher, batch, or induction, I would say is fixturing, maintenance, labor, and oil, between others, right? Like, well,
Right.
gas, of course.
Oh yeah, the utilities,
gas, of
and
course,
so on. Yeah.
right? But what's like the big differentiator, the differentiation on maintenance, right? Or on fixturing? Pushers, they use a bunch of trays, right?
Correct.
Right. On batch, you use, I believe, a little fewer than on pushers because you don't have to be constantly loading and reloading. Oil, as you mentioned, we're only using one tank on a pusher furnace against other tanks. But do you think there's an ideal mix or an optimal mix if it was, well, in this case, it's up to you, right? But for a captive shop, to a green size shop, just to go pusher or batch, or have just a mix between, because what I have seen in my experience is that most of the guys, they either like to go pusher or like to go batch, but there are very seldom OEMs like captives like American Axle that they have a mix.
It comes down to the mighty dollar. Cash is king in there. It depends on the part that you're running. If the components that you're running, you cannot justify, or you have a mix of parts that you're running that they require two different processes, and the changeover and so on do not favor running a pusher, you might have to get a batch. But at that time, it becomes quite expensive to set up a batch line. Not only a batch line needs its own individual equipment and oils and all that, but the foundation and so on that it requires to build a batch with the pits and the cars and so on, it adds up to be quite a bit. So the best way is just to sit down with the numbers and the cycle and the material that you need to run to see what makes the most economical sense. Now, the way we ended up with a lot of batch in our process was because we started out with batch. We started out small. A lot of our units that we have, generally, we start out a manufacturing facility with 2, 3, 4 batches, and as the volumes increase, as we prove our quality and our product to the local industry, as then our volumes increase, and we can justify in that case to go into a larger production requirement that requires us to go into a pusher. But it's always based on the bottom line, your cost per unit of production, what dictates which way you have to go in the process.
And there's also the taboo or the idea in the market that some of the big three, GM, Ford, or Chrysler, some customers of us, I'm not saying all of them, they say, they can only run one of their customers and parts on one system, on one furnace. They cannot be switching systems, right?
Yeah.
So is that also a big thing to consider, right? Yeah. Because if you buy a pusher, let's say you would like to keep it always full, right? But right now with the semiconductors going down and the volumes being down, the only furnace that is validated might be a 3-row pusher, right? Right. And you're running half a row, right? Which will be more cost beneficial on an IQ furnace, on a UBQ, right? But you cannot do it because of validation. What can you tell us about that?
Well, you said the magic word there. It's a validation. Every part that is made in automotive, it has to get validated and tested extensively And then the data is shared with the customer and or reviewed with our own quality teams. So typically what we do is, we start out with a pusher or whatever. We dedicate that machine to one product, but we have maintenance times,
Right.
downtimes that the production has to go. So we try to keep the validation for a couple different, so we have backups. Now that makes it more difficult for Creo or other commercial heat treaters to do that, but that is something that has to be taken into effect, and that is a CQI requirement. You have to have the validations to be able to process this equipment. So it makes a big difference for you and as well as us, because the volumes are down, and to keep the cost per unit in an acceptable range, you have to have some flexibility to be able to run it. So my recommendation would be always to have a backup plan. Your backup plan could be one batch for some of the small, if your volumes get small, or you have to be flexible enough to be able to run it and show metallurgically or other ways that the product that you're making is as good as what it is coming out of the other furnace. Every furnace, I don't care if you build 10 batches or 10 pushers side by side, same guy building them, they will have their own individual characteristic. So you have to work, you have to validate each furnace by itself, and get those data checked and tested, do all the due care testing that's required.
And as you say, I believe one of the downsides of batches is that you can build, let's say, 10 batches on the same project, but as the furnaces are aging or they're having maintenance issues, or maybe one of those they don't get calibrated that soon, or they can have like heat leaks or something like that, you're going to start to see different results from the same part running on the same recipe from furnace to furnace, right? And
Absolutely.
when you add it up by the unit of 10, you have a lot of discrepancies between batches. I do know an installation when they have a bunch of batch furnaces and they press quench, right? So they take a lot of time from the first load that they press quench on batch on a rear door to the very last. So that's like an hour long, and then you multiply it by 10, you're going to have a very, very different result, right?
That's right.
So things like this you have to consider. But having said that, right now that the volumes are down and you cannot feel the pushers, they just can 6 or 7. You have an opinion on that one?
You know, it goes down the same parameter or the same level of thought that as what we just already discussed. We do a lot of press quenching out of pushers, and we did a lot of press quenching coming out of batches too in some of our Asia facilities. It is very true that the first part coming out versus the last part makes a lot of difference. But again, it comes down to the flexibility that you need to have for the various parts. If you have 100,000 units that you have to build in a year, or a couple 100,000, that's a pusher lot. Otherwise, you're going to have a lot of labor there to process the batches to get those out. And the batch, it's the variation in the load sometimes does give you a little bit of a sleepless nights until you get it dialed in.
And now let's change the subject to a kind of a trendy one, which is called automation. Most of the furnaces nowadays have a bunch of automation already on it by design. I'm talking about the pushers or the new generation of batch, but there are parts that they go like, well, this is semi-automatic unit, because you have like on the batches, you need to have like an operator pressing buttons on the transfer card, putting the load in, placing recipes in. That semi-automatic how I understand it. On pushers, the automation is way more because you just go start, and if the loads are there, they'll keep going, right? There's also a big challenge that heat treaters we have, which is the loading of racking. That the loading of racking, because we have a lot of distortion and different parts, we cannot have like robots. What's your opinion on the automation, on what can you tell us about the level of automation that every heat treater should have by now in the 21st century, and what's like a level up on state-of-the-art facilities like the ones you actually manage? Because automation is expensive, right?
Oh, it's very expensive.
On the long term, it's a good game, but sometimes I won't recommend such a high level of automation for a commercial heat treater, because it has to have a lot of flexibility, and the capital expenditure is very high at the beginning.
Correct. So yeah, you're 100% right. The cost of going 100% automation is very high, but with that high ticket comes in a level of quality, a level of repeatability that you do not get from a human loading or a human setting up the alloy. And nowadays, it's a human showing up to work.
Right.
Yeah, COVID's been a huge influence on people going full automated with their heat treat, and some of the newer, more technologically advanced equipment that's out there does require that. It pays off to do that, and again, it comes down. One of the biggest things that it comes down to is very low. It makes it very difficult to justify automation. If the quality requires it, that's one thing, but you got to be able to come up with validation of why it is essential to do it. We've done it both ways, and obviously there's one part of it that the system runs automatically by itself, loading and unloading the equipment, even the trays. And the technology is now there with the camera systems and so on to be able to load the trays and fixtures and monitor the process a lot more closely. But by the same token, the costs are high, and the cost of maintenance on it is high. The cost of having somebody monitoring the level of knowledge that it takes to be able to debug a system now. With robotics, you're going to need to have a controls engineer or an electrician that has a PLC and robotics experience all the time.
Plus, those guys will need to understand how the machine works and the risk that it atmospheres, and
absolutely,
because there's a bunch of guys that they know how to handle robotics, but they don't know anything about heat treat. And if we're dealing with a machine that can have like an explosive atmosphere, if not handled well, you don't want to have a guy pressing PLC IOs without knowing what's going to happen, right? So I believe there's a big risk, because there's fewer and fewer people that actually understand furnaces, and they understand the PLC and automation. So I believe it's a hard one.
It is difficult. You have to be very, very involved, and you have to debug and run the system. So even though nowadays I prefer to use an integrator to do the robotic installations and the process, you still need to have myself or somebody from our team, from our facilities, or somebody, another OEM that's providing heat treat equipment to be in lockstep with the integrator to make sure that nothing goes awry in the way they're programming. And then the debug and the trials are extensive to make sure that there's no issues or there's no cause for danger in the facilities.
Thanks for sharing that. Now, I just would like to change a little bit of the subject to the electric vehicle, the EVs. I know that American Axle has a very strong approach to it, but my question has always been like this to big companies with a lot of capacity. But with the transition to EVs, there is an expectation that volumes are, especially for what we do, transmissions are gonna drop significantly without even counting the autonomous vehicle. So, do you think that all that capacity that is out there with all those pushers and batch can be filled with something else? Or EVs are going to still require heat treat for certain, I do agree with that. But the technology is smaller, a little bit more precise. So what do you see in the future? What are your predictions that that is going to happen with all these big pushers that have been installed in the States, in Europe, in Latin America, in Asia? Will companies say, we need to find a new use for these machines that are very expensive? They have a bunch of that have a lot of line time. They require a lot of floor space, or they're going to switch technology?
Well, the technology is changing. The EV market is definitely a watershed moment in the industry, in the heat treat industry. And there will be changes coming. I kind of compare today to the mid to late 80s, where there was, I don't know what, there's a 50, 60 computer manufacturers then. Everybody was making a desktop computer. Mine is greater, mine is IBM compatible, and so on. So today, that's where we are. There is a lot of different manufacturers that are starting to make EV motors. And but the EVs, in my opinion, it will make a difference in the market, but it will make a difference within the portion of the market that is automotive. Okay. Your building components, some of the heavy equipment, your aerospace and so on, they're not, at this point, they're not getting affected by the EV market. So that portion of the market, whether you want to call it 25% of the market, heat treat market, is automotive, that portion is going to get affected. But the way I look at it, humanity is growing. There's always going to be more cars needed. There's going to be more buildings needed. There's going to be more planes needed, hopefully, for travel and so on. So whatever we lose in production that is required to be done in a gas carburizing type of equipment can be used to make other type of parts that are still need to be heat treated.
And what about gas consumption and going green? We burn a lot of gas because gas is effective to heat things up. But there's also the trend to go electric. Do you envision furnaces to be electrically heated in the future, or do you think gas is going to remain like the energetic of choice?
Well, there's two factors in this. One is, as you said, the environmental and the cost of, look at the cost of natural gas. It's doubled in the last 6 months. So we're going back into the early 2000s or 2005 time range that the cost of natural gas is increasing. And even though my equipment is all recuperated and highly efficient, there's a lot of people out there that don't have it. So all the energy companies are all out, hey, I got the latest and greatest energy savings for you, and you got to try my stuff. Or the next guy says, you got to try my stuff. The other major factor in it is the environmental, with the NOx and CO2 levels. It makes more sense now than ever before to start looking at electrically heated equipment. And also, the other mere fact of it is that the manufacturers of the gas train, the historical ones that we've always used, they've dropped the ball so severely in the market that now there's other, in the last show, there were other gas burner manufacturers out there that I visited. And but between the suppliers not giving a damn about the consumer of their product, or the OEMs having delivery dates and so on, and the environmental, it's pushing the industry more towards, in my opinion, towards electrically heated.
I believe that's a great answer. It's all about environmental, but at the very end, the demand will actually ask for what it needs. Now talking about demand, and just my very last question, um, what's your expectation about these semiconductors demand being that low? When do you think this is going to get over on the automotive market, especially because semiconductors and chips are used for many things, right? And automotives are taught to believe that they pay the lowest because they're high volume. So people mentioned that computers are going to start to regulate, of course, iPhones and cell phones and computers for Bitcoins and video games, because those are big margins for the semiconductors, right? And
Exactly.
when they have an extra capacity, they're going to turn again with the big automotive consumers that they pay very low because of big volumes. I'm going to say, okay, we have now semiconductors. Do you have some insight, or what are your expectations in the near, middle, and long future for this semiconductor fiasco that it's happening right now?
My insight is what I read in Wall Street Journal and so on, that this is going to continue for the next 12 to 16 months at this pace. And it's exactly as you said it. It's people can the semiconductor manufacturers are making a lot more money than selling to phone makers or electrical gadget makers than to automotive. So during COVID times, when people stopped buying automotive or cars and so forth, the sales fell. People were still buying their phones and their little gadgets and having it delivered to their house. So they switched their business manufacturing towards those. And it's going to take quite a while, according to Wall Street, before it comes back towards automotive again.
Thanks for doing that. Thanks for sharing this and taking this time to the Hit Read podcast. Fred, it's been very nice talking to you. Thanks for sharing your knowledge, your experience with the audience. And the last but not least question of the show. Fred, you've been in the industry for 35 years, all about heat treat. You have been a furnace designer. You have worked on captive as a captive. You were a furnace engineer. So basically, all your life it's been around heat treatment on the OEM side, on the captive side. You have visited many countries. You have met many people. You have had many relationships with companies that are suppliers for heat treat. You have purchased many furnaces. You have done many upgrades. What will be a personal advice or experience that you would like to give to the new generation? There's also the common belief that the people with experience in the field is retiring, and we are not refilling that capacity with younger engineers. And I do believe mentors and guys like you are very needed right now in our industry, actually, to make that push and that transition of knowledge. I'm not saying that you're old. I'm saying that you have a bunch of experience. Don't take it the wrong way, right? But maybe in 10 years we'll be having this podcast with another heat treating engineer of American Axle that they just started today. So what would you like to share with those guys that are starting to get a leadership role on heat treatment, that are 25 years old, but they want to make a career out of this industry?
Okay. Well, Carlos, you may not know this, but actually I started out in the IT business. That's how I got into the heat treat business.
I didn't know that. Okay.
Bob Williams, God rest his soul, had hired me to come in and install his computer systems.
That's why you're so picky with controllers, Fred. Now I understand. It all makes sense.
Yeah. That's how I got into the heat treat. And he found out I'm an engineering student at the time. And that's how I got into the business. And with Bob, it was School of Hard Knocks. Both Jason and I were knocked around a little bit by Bob, but he put strong values in us as far as being able to endure and just keep up with the this is a very difficult field to be in at times, okay, compared to the other more glamorous, Wall Street or IT or so on, that you don't get your hands dirty to come into the into this industry. And you're 100% right. There's not many people coming into it, and the turnover is rather high for the new generation coming into this field. But we can mentor them, we can support them, and we have to make it worth their while to come into this industry. Right now, when I sit down with students from University of Toledo or so on that have conferences, or they want to pick my brain about the industry, this is one of the first places I push them in, because there is a lot of vacancies here. There's a lot of great companies out here that the OEMs are great companies. The captive heat treats and the commercial heat treats are great companies to work for. And the demand is going to stay there in different forms, but they have to have perseverance and dedication to be able to put up with the long days in the hot, sweaty places and in different parts of the world, and take that experience, the hands-on experience, along with what they learned in school, putting it all together, being able to carry on a tradition of being able to design a great furnace and then make it run. You have to get satisfaction out of doing that kind of work. And there are people out there that will do it. We just have to find them and keep them. The keeping part is it's proven to be much more difficult than even finding the people.
You have to get them motivated,
Exactly.
give them challenges.
You've done a great job with the team that you've had for the last 5 years. You've done a great job. It's great to see that team with you in the last month at the show, and you've done a fantastic job. So keep doing what you're doing.
Thank you so much, Fred. It means a lot coming, especially from you. And just would like to thank you again for your time, sharing experiences with us, being on the Heat Treat podcast, having guests such as like you in here, brings a lot of value to the new generation. Hopes this gets a lot of views. So we would like to thank you and remind our audience that we're uploading weekly podcasts with power players of the industry, YouTube, LinkedIn, Spotify, the Heat Treat podcast every week with power players. Today we had Fred Hamizadeh, director of Heat Treat at American Axle. Have a great day, guys. Fred, thanks for making this happen.